So you have a number of different kinds of immune cells that have the sole goal of keeping your body from getting sick and fighting off existing illnesses. The first thing I want to talk about is, where are those cells made? Most of those cells are going to be made in your bone marrow in a similar fashion as blood is made. Basically, you've got stem cells in your bone marrow that are going to create new cells, and those new cells are going to mature into different kinds of immune cells. These immune cells will then go to different places in your body. The ones that really migrate are the B cells and the T cells. The T cells, and we'll talk about those later and exactly what they do. The T cells are called T cells because they go, when they're immature, to the thymus, which, remember, is a gland right above your heart, and they are going to mature in that thymus. The thymus in children is actually much, much, much larger than it is in adults. And the reason that it's larger in children than adults, if you think about it, is that their immune system is learning. So basically, they've got a lot of cells in that thymus that are going to be learning, developing, growing, kind of specializing. And if you've got children, you probably know that very early in their life, they start to get sick like all the time. This is because their immune system is learning to fight off infection, so it's not very good at it yet. Eventually, they do learn to fight off infections, and then their immune system becomes a little bit more normal. But there's always that, about first year that they're in daycare or school, that they are sick pretty much constantly, which means you're sick pretty much constantly. It's fun. The B cells actually mature in the bone. Once these cells are mature, then they're going to migrate to different places in your body. Some of these are those lymph nodes that we talked about before the break, and some of these are going to go into areas like your spleen. Your spleen, in a way, is it's not a lymph node, but it's set up in a similar way, where it's basically a maze that blood is going to go through, and it has something called white pulp, and that white pulp is all white blood cells, and these white blood cells are basically going to sort of come out of the house of horrors that is your spleen and kind of jump on the pathogens or the damaged blood cells or even cancer cells, and they're going to destroy them. So if someone's spleen is removed, then this means that they may have a less a good chance of fighting off infection. You can still live that way, but it would put you into sort of an immunocompromised category where you're going to just be a little less good at fighting off infections that are around. So in the lymph nodes, there is an afferent vessel and an efferent vessel. The lymph arrives through that afferent vessel. Remember, arrive, afferent. And it exits through the efferent vessel. This, again, allows that lymph to go through this kind of maze structure. And as it's going through the maze structure, those lymphocytes are able to locate cells that are dead, damaged, dying, cancerous, or infected in some way, and they're able to jump on those cells and destroy them. This prevents those cells from having to look through all of the blood in your system. You can imagine that you have millions and millions and millions of blood cells. And what we really want to do is we want to sort of have checkpoints where we can look at a small number of cells and look at which ones are infected and kind of filter those out. It's much harder if you think about the entire system. So this is why you would have lymph nodes. It gives your body sort of choke points. And if you remember what we talked about before break, we talked about where those lymph nodes are located. They're basically located at places where they can keep the infection from spreading. So the neck, the armpits, that's going to spare the trunk. Because if you ingest something, you get an infection in your throat. You don't want it to go down to your heart, right? Armpits are going to help the heart. You've got some in your groin. Hey, guess what? There are entry points down there, and we don't want that getting into our trunk either. And you have some around your intestines because you might eat something terrible. There are also some in your elbow and in your knee. And what those are going to do is try to keep infections from even reaching the armpit, right? We don't want things to get overwhelmed before they reach those points. I guess it's your body's way of flattening the curve. I'm sorry, that was a terrible joke, but you guys know me for my terrible jokes, I guess. In addition to these lymphatic tissues, you also have lymphatic tissue in the back of your throat. You've probably heard of the tonsils. Those are involved in trying to kill infections that are occurring in the throat. There you've got something called MALT, which is mucosa-associated lymphatic tissue. Anywhere you have a mucosa, which is basically anywhere you've got an opening to the outside world, you have MALT. And basically this is an area kind of dense with immune cells that's going to try to prevent infection from spreading. If someone has something like chemotherapy and we kill off their bone marrow, which happens with like leukemia chemotherapy, you try to kill off the bone marrow, this means that they can no longer make these white blood cells, which means that they're incredibly immunocompromised because they don't have the ability to make new immune cells. In the next video, what I'm going to do is I'm going to talk more about the different immune cells, what they do to fight infection, and different things your body does to fight off infection.